This is a quick demo of the F46, a GRBL CNC robotics controller based on the STM32F407 ARM Cortex-M4 microcontroller. GRBL was originally developed for the Arduino AVR328 microcontroller and only supported 3 axes. I've ported GRBL version 1.1F to the STM32 microcontroller, and it is called GRBL32, and it will support up to 6 axes of coordinated motion. I've also extended GRBL to support additional G-codes to handle more advanced tasks such as digital input and outputs, and also analog outputs in the form of additional PWM channels. The F46 runs up to 500K pulses per second for each axis while under 6-axis coordinated motion. This is much faster than the top speed of 30K pulses per second for the Arduino-based GRBL. The F46 connects to all peripherals through 12 RJ45 ports, which uses the same connector as Ethernet. Shown here is the axis for the driver module, which will accept a Pololu-style stepper drive. Next is an axis breakout module, which will connect to the step and direction signals to an external driver and also connection to limit switches. Next is the PWM signal breakout module with connection to 4 RC servos. The F46 can drive up to 8 PWM signals or 2 of these modules. Next is a generic breakout modules for the 9 pins. Note that the housing of the connector is the 9th pin, which is connected to ground on the F46. Note that only Cat7 Ethernet cable has the shield connected. The generic breakout module is used for digital outputs as well as spindle and control connections. Last is a dual driver breakout board, which connects the control signals from one axis to 2 Pololu drivers. This is for connecting one axis control to 2 drivers in a dual motor application, such as a 2-motor gantry. I am mounting the F46 and the breakout modules on a plate to run a quick demo on my custom-built CNC system, a typical XYZ and spindle configuration. This is the driver for the spindle motor. Next to that is 3 industrial stepper drivers driving axis X, Y, and Z. They are CompuMotor OEM 750, configured for 25,000 microstep per revolution. This is the popular TB6560 driver configured for 3200 microsteps per revolution to drive axis A. I use 2 Pololu A4988 configured for 3200 microsteps per rev to drive axis B and C. These are some LEDs to show digital outputs. These are some buttons to simulate digital inputs. After wiring up everything with Ethernet cables, the system can look quite busy. In the back are 3 stepper motors representing axes A, B, and C. There are 8 additional PWM channels, but I only have 6 RC servos handy. First, I will start the universal G-code sender. I will connect the F46 with the standard baud rate of 921.6K. The older 115.2K baud rate firmware is also available for compatibility with older software. Here are the usual GRBL parameters with the additional values for axes A, B, and C. I will run a homing cycle for the system. After finishing the Z homing sequence, the system will home both the X and Y stages simultaneously. At the end of the homing sequence, we set the home position to work 0 for all 3 axes. I will load a simple G-code file, which will demo some digital I/O's features and run a circle on the XY stage with the spindle on. and then move the RC servos. First command is M62, which will turn on all digital outputs. Then a M66 to wait for a digital input to go low, and we'll push a button to simulate that input. Some motions to demonstrate all 6 axes in motion. Then spindle on and run a circle. Then a M66 to wait for a different digital input to go low. I will push a button to simulate that input. Move all axes back to 0. Move the RC motors using M67. Then M63 to turn off the LEDs. If you're interested in the F46, please visit us at tomsrobotics.com. Thank you for watching.